So I saw this question somewhere. It got me curious about it, and I think the solution it's given is different from what I kind of came up independently. So I kind of want to share with everybody here. So to solve this, really, we need to have some knowledge of factoring and some formulas for factoring. In this case, so we're going to go through that knowledge first, and that will make it a little easier, make things more obvious. So the thing we need to know is that when we have a cubed plus b cubed, we need to know that that can be factored into a plus b times a squared minus ab plus b squared, b cubed, sorry. So, and likewise, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b cubed. These two formulas are very useful. It's very useful if you remember them, just like how you remember the a squared minus b squared, what that factor into. So once we know these, there's a simplified form of these, a special case where if b is 1, then that becomes a cubed minus 1 is equal to a minus 1 times a squared plus a plus 1. So as we can see from here, this part is really very similar to here, right? So once we know this, we can say, what if I multiply both sides by, say, x minus 1? Because that will make the left side take this kind of form, right? So we say we multiply x minus 1 to both sides of this equation. X minus 1 times x squared plus x plus 1 is equal to 0 times x minus 1 is still 0. Now this side, based on this formula, is equal to s cubed minus 1 equal to 0. And that is equivalent to saying x cubed is equal to 1. And once we get there, this is x to the 17th power. I mean, we know that x to the multiple of power 3 is also going to be 1. So we kind of using that knowledge, we say x to the power 17 plus x, that equals to x to the power 15 times x to the power 2 plus 1. And we know this is equal to x to the power 3 to the power 5 times x to the power plus, no, this is plus x. And we know this is 1, so 1 to the power 5 is still 1. So this whole thing is 1. That becomes x squared plus x. Now this part, using this, we know that this just equal to negative 1. There is your solution of this. So the bottom line is that these equations are very useful when you're doing factoring, or the reverse of factoring, which is this. It's very useful. All right.